In this video, I'm going to go ahead and jump into solving this trigonometric proof problem. If you'd like a more thorough explanation of proofs, watch the video called Trigonometric Proofs Part 1 on my YouTube channel. The first step in solving this problem is picking the side of the equation that you want to prove the whole equation from. Generally, I find it easier to pick the side of the equation that has the most stuff in it, so I will prove this problem from the left side. So, in this problem, I'm going to manipulate the left side of my equation until it matches the right. So, my last step should read 1 minus cosine squared theta is equal to 1 minus cosine squared theta. Now, I'm going to begin this problem. I'm trying to make the left side of the equation match the right. I notice that the right side of the equation has two parts, the 1 and the cosine squared theta. And the left is all one big part or cluster. So, to make it more like the right side, I'm going to separate it out into two parts. I can do this by using the reasoning of this algebraic statement, which is a minus b over c is equal to a over c minus b over c. It may help you to understand this reasoning if you think about this situation with numbers. For example, 6 minus 4 over 7 is equal to 6 over 7 minus 4 over 7. If we apply this to our problem, secant squared theta is a, 1 is b, and the secant squared theta in the denominator is c. So, we can write secant squared theta over secant squared theta minus 1 over secant squared theta. We can then simplify the secant squared theta over secant squared theta to 1 and bring down the rest of our problem. And now, if we look at our trigonometric identities, we see that 1 over secant squared theta is equal to cosine theta. This same basic principle applies to secant squared theta. 1 over secant squared theta is equal to cosine squared theta. So, we can bring down the 1 and the minus sign and replace the 1 over secant squared theta with cosine squared theta. And now, we have made the left side of the equation look the same as the right side of the equation. So, we bring down the right side of the equation, and we have finished our proof, because the left matches the right. If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.